like they can do. Okay, cool. So I'm
Uh, okay, hi. So I'm Blake. I'm a research assistant with Polkit in his lab, and I have worked a lot with getting things up and running for with both Google Cloud stuff and AWS stuff for our lab. So I was just going to give a brief overview of how this stuff works, and then feel free to, I guess, ask me any questions you want, and you can just interrupt me if you have any bleeding questions you'd like to ask. I guess before I start, just like any questions at the beginning, or like, can you hear me okay? And I have some slides, but just curious.
Think
Yeah,
all
we can
good.
hear you fine.
Awesome. All right. Oh, whoops. Let me share my screen. Okay. So, yeah, I guess this is mainly just going to be about, oh, it's not full screen. Interesting. Okay. This is mainly going to be about how you guys can use your AWS credits that you've been assigned for this class, and just a brief overview of how the software works, and then some potential ways that you can save on your credits so you can make them last as long as possible. Because when you're running a lot of stuff at once, which you may or may not need to do, it can eat away pretty quickly. So I think so. Just a brief overview. So there's really two main services with AWS that you are going to care about with your workflow, and that's EC2 and S3. So EC2 basically is the compute engine. This is where your actual machines are going to be running, and you can monitor them and make changes to them as you want. And S3 is the file storage component of AWS. So this is where you can store model files, data, any logs or plots you want to save, and any other intermediate files that you may need. There are a lot of like jargony terms for this stuff that can be kind of confusing because AWS is really a bundle of like 30 different pieces of software that are sometimes a little bit confusing. So I think the core of what you need to understand is that you have instances, which are just machines. You have AMIs, which are machine images. Sorry, this is a bit of a wall of text. So you have machine images, which are basically like templates that you can launch many machines from. So you would essentially treat this, it's similar to like a Docker image where you configure the machine how you like, you create an AMI, and then you can boot as many instances of that image as you'd like to run multiple things at once. And then there's two types of instances, which are on-demand instances, which you can start at stop and stop when you want, and so they persist. They're never interrupted, but they're very expensive, comparatively expensive to other options. And there's spot instances, which are basically you bid a price and you get the instance for as long as your bid exceeds the minimum bid. And these are much, much, much cheaper in general, but they can be interrupted, so you need to make sure you balance your bid correctly. The nice thing is that the bid is like you always pay the minimum, so it's not like if you bid a really high amount you're paying what your bid is. And the last thing is a spot request, which is basically how you request a spot instance, either using command line or using the console. But I think there are other tools for that as well. Yeah, so just like a brief overview of how EC2 works. So you have these AMIs, which you've created that have different configurations for the different workflows you might be using. You make a request through the console, which includes an ID pointing to one of these images. Um, this gets queried to the console, to the compute engine, and that launches an instance, which is just a machine. And similarly with S3, you might have an instance running. S3 is basically a file storage system, and it has what is known as a bucket. And a bucket is essentially just a collection of files. And the reason you might have multiple buckets is so you can have shared different access privileges for different buckets. But I think for most cases, you'll just have one bucket, which has all of your experiment results, model files, and so on. And you can also have data stored there that you can pull quickly because it's faster to pull internally between instances and Amazon storage than to pull from your local from your local machine your data every time. So yeah, you might have some code running on your instance. You pull some data from your bucket and you store the files that result from you training your model to your bucket, and then you can pull those later. A small caveat is that there's no such thing as that actual folder in the buckets. They're only leaves. So if you want to pull in like a directory, you have to use like some regex stuff, basically using wildcards to pull the things you need. But I think that should be relatively straightforward, especially if you're just saving plots and things. You can pull them up in the console in the GUI, and it's not too bad. Yeah, so I guess how do we get started? I'm just going to run an actual little bit of a demo for you guys. Let me get my browser going here too. So yeah, so first thing you're going to do is you're going to sign in to your AWS account, and that's going to bring you to the dashboard here. And so what we're going to do first is we want to create an AMI that we can boot from. So for me, I'm just going to install a couple basic things to use that I know I'm going to need later on. I think for you, you can install more packages that you need, or I think a better way to do it is just to have a Docker image that's configured the way you want it, and then you can just pull that Docker image when you run stuff. And that way you can keep things up to date as you add dependencies and so on. But yeah, so you go to this console, you click Launch Instance, which is going to bring you to this selection. This is basically saying what is the basic AMI that you want to boot from. You can use AMIs that you already have, but I'm going to assume we have none, so we're going to boot from the default Ubuntu instance here, which will then the next thing you can choose is the type of machine. So unlike Google Cloud stuff, AWS includes GPUs in the instance type. So if you want to use a GPU, you need to select a GPU instance up front. You can't add them as like an extra parameter. But for the purposes of what we're doing, which is just configuration, we can choose a really cheap instance. They actually have this free tier here, which won't use any of your credits for configuration stuff. So, I can't see the the button here because of the Zoom window. Yeah, so we're going to pick the micro instance, and we're going to say review and launch. Yeah, so when you create an instance for the first time, you are going to be asked to select a security key. You can either use an existing key, or you can use an existing key, or you can create a new key for this instance. When you create a key, just for I guess explanatory purposes, I will do so. You create a key, you give it a pair name, so like example key, and you have to download this. So this will basically give you your private key that you will use to SSH into any of your instances from a remote console. You will save this, and then in your console, let me see if I can move this over to the same window. You'll move that from your downloads to wherever you're storing your keys. I have them in AWS Keys, but you can do it in any way you want. And you also need to change the permissions for your key so they're only readable and writable by you. And then if we create any instances with this key pair name example key, then we can pass this key as an identifier to whatever SSH command we're doing, and it'll allow us to access the machine. For my purposes, since I have a key set up, I will use my existing key, which is my tutorial key. And basically, I am acknowledging that I cannot access these resources at all without the key access. And you can't get the key back if you lose it. And you can't really easily share keys. So I think the best, I'm not quite sure the best way to share keys between users might just be to have some sort of secure zip that you can share between each other, or just like on a thumb drive and then delete it. I'm not sure. There seems to not be a super good consensus on how to share keys for a specific instance. There's like security roles, but those don't work too well. So I will actually look more into that, and if I find a better solution, I'll let you guys know. But for now, I'll just launch this instance. And so when you do this, it will basically make the request, and then it might take a while to boot up. The beefier instances tend to take a bit longer to initialize, but these really small machines with like a relatively few cores and no GPUs boot pretty fast usually. So hopefully this is running. Yeah. So if you click on the instance you want to SSH into, you can get the login information at the bottom right, which will give you the IP address. And then you can SSH to this machine using you pass the path. It's like -i and then the path to your key. And then the user is Ubuntu and then the IP address. So this should let me log in, assuming it's running. Yeah, so now I'm in the terminal for this instance running remotely. First thing we want to do is update our package list. So we'll do that. And because we're going to install the stuff that we need to run a small dummy script which I will show in a second. So first we need to install unzip, and then ironically we need to install AWS. Yeah. So, and then this is a really good time. So basically, this is a good time to install any packages that you need. I'm going to install Docker and then just assume that I am going to run everything inside a Docker image. But if you want to run stuff in command line, then it's nice to install everything you need now so you don't have to run like installs for packages on your startup every time you launch an instance from this image. So the last thing I'm going to install here is Docker. Which can take a few minutes. Is everyone good so far? Any questions?
I guess just one if we're waiting for Docker to oh, never mind. We can come back to it.
Okay, sure. I mean, if it's relevant, you can ask it. It just depends.
No, it's a more general question. We can.
Okay, sure. Okay, so now I should have Docker here if I run this. Cool. So I'm going to install. I think ideally for you, you would probably have a Docker file that has your stuff in it that you need. But I've been a bit lazy here, so I'm just going to install a default Python image, which doesn't come with anything. I mean, maybe I should install a Conda image, but I'm going to install this one and then just install a single package that I need inside the Docker image, which I can actually show you how to modify and commit to existing images, which is kind of useful to know when you're working on remote machines. But yeah, this might take also a couple minutes if you want to ask that question. Oh, never mind. Okay, cool. So now we have this image. If you list your images, it's there. So yeah, so we want to run our image to make some changes. So we're going to run in interactive mode this image here. And this is going to run bash. And oh, it ran Python. Interesting. Let me run bash. Okay. So yeah, so basically all we're going to install in here is NumPy. All right, so now from when you're running inside this container, so Docker boots many containers off of images, similar to how Amazon does it with instances. We need to somehow detach from this running container without killing it. And the way to do that is Control P and then Control Q. And it's a little bit janky, but now if we run this command, we see that we have one running container, which is an active version of our image, but we've made some changes. So the best way, so we can copy this container ID, and then if we run commit with that container ID, and we name it tutorial, I'm just going to name this so my scripts work correctly, but you can name this whatever you want, or you can actually name it the same exact tag and name, and it'll work just fine. So this should create a new image with this name and the modified contents of the image. So now if we run what did I call it? Tutorial test AMI. This is going to run our image. If we import NumPy, it should work. Yeah, so cool. All right, so our instance is pretty much ready to go now. We've installed everything that we need. So the way to create our AMI is to just go back to this console. Make sure you click on the instance you want to create an AMI for, and you'll go to Image, Create Image, and then you'll give it the name that you want and potentially the starting volume, the starting memory volume or disk space that you want for the image going forward, and so on. And this you can modify later. But since I've already created, this takes a while to actually construct this thing, so I've actually created one already in my AMI, as you'll see it under AWS tutorial image. So going forward, we're going to use that. So you might be wondering, what's the best way to run a lot of stuff at once? It can be kind of annoying to manually create a bunch of instances and then SSH into each one and upload your code, pull your GitHub repo or whatever, and then launch stuff. There's like a nice tool for this. Let's see if we can get to it. It's called Doodad. So yeah, so basically how Doodad works is you can think of it as like a middleman between you and the instance generation, where it'll bundle all of your code and any data that you mount to it and put it on S3 to then be pulled down by an instance. So it constructs the startup script for the instances that it creates, and it saves all the data and code that it needs to run, assuming you configure it correctly. And then it'll store any of the folders that you want to store to an S3 location that you can get later. So it's sort of a way to parallelize and increase your throughput by essentially like iteratively launching a bunch of jobs at once. Say, for example, you wanted to tune a hyperparameter for a specific thing, like a learning rate or batch size or something. You can essentially construct the list of all possible types, all possible configurations of the experiment that you want, and you can launch one instance or many seeds for each job, and it'll launch those for you. Yeah, so I think for this case, we're going to just run two different scripts to show you how to run just a basic script, and then how to actually mount some data and some code, some module to Python that will then work correctly when you run it on the remote instance. But yeah, so that's basically the gist of it. So if we go here and now we want to, this instance we can, since it's done its job, we can actually go in here and terminate it. So there's actually a couple different options here. So stop will let you pause the instance. You'll lose whatever's running in progress, but the memory or the disk stays there, and all the data on it stays there. So any configuration changes that you've made will be there, assuming that they survive rebooting. You can reboot as well, and you can terminate, which will actually delete the instance. And since all we did this for was to create the AMI for booting, we can actually just go ahead and get rid of this instance in general. So I'm going to show you basically how my code is structured to use Doodad, and then I will hopefully launch it with no problems. And if I can just get to, man, Zoom is really getting in my way here. Yeah, actually, hold on. Okay, so yeah, so the first thing we have a simple script here, which is just a script that imports Doodad as a Python library, calls getArgs to get a dictionary of all the arguments that we've passed to the script, and then prints out the argument with key input. So this is basically, we would pass the input argument to our script. First things first, we have to, and we're going to run this with Doodad. So the first thing we have to do is install Doodad, which is a little bit more complicated than it should be. I'm going to remove my current installation so I can show you. So we'll first clone this Doodad Git repository, which will then give us our Doodad folder. We'll cd into there, and then we need to check out the older version of Doodad, which actually works with EC2, because they changed it to a Google Cloud thing, but they didn't back support. So this is going to be v0.2, and that gives us the commit that we need. And now we're going to install the requirements, any required modules that we need. So yeah, so this should install everything we need. I've already installed some of these, so it was really fast, but it may take a few minutes. And yeah, so now I think we're pretty much ready to go. One last thing we need to do is to export the location of the Doodad the Doodad parent folder, to our Python path so that it can be imported as a package, because there's no install script for the package in this current version. So yeah, so if we export this to our Python path, then if we go out here and we try to import Doodad, it works. All is gravy there. So yeah, so now the next thing you're going to do is you're going to go into Doodad again, and you're going to run in your scripts. There's a setup EC2, which will automatically configure everything for you. You would basically say yes to everything in here. I'm going to say no, just because there's like a ton of prompts, but you just say yes to everything, because it has to create a separate key for every single region, and it can be a little time consuming. But if you just say yes to every prompt in there, it should work for you. One caveat is that you need to set your environment variables. Actually, let me open a new command line and see if it asks me to do that, so I can show you how to do it. Let's see. Okay. Okay. So if I run, oh. Okay. Yeah. Okay. So it's going to ask you to set these different environment variables. These are super secret. I would not share these with anybody, which is why I'm trying not to pull up my private configuration, because they're stored in plain text, which is kind of crazy. But these are basically accessible if you go to your account and you go here and you go to your security credentials. You will see your secret access key, or you'll generate a new secret access key and a public key. So these you will basically store to whatever these environment variables they tell you, and they're pretty self-explanatory. So this one is the public access key, and then it'll ask for AWS secret key, and then like region default, and that can be whichever region you want to use. So, but since I don't want to show those things in a recorded video, I'm going to basically, I would source, I can store them in somewhere that I thought I did. Well, okay, I don't have them on here, but if you save them to an sh file, you can basically source them. You can run source and then whatever config.sh you can have in this config file. You would have basically export like AWS secret key equals and then whatever it is, and then you would have that for each of the 3 variables. And then if you call source on that file, it'll set those environment variables for you without you having to type them into the terminal or whatever. So I have it all configured already. So what this setup script does is it creates a role that Doodad can use to create instances, and it creates a bucket for you based on whatever your bucket name is. Mine is, I think, AWS Doodad bucket or something, but I think bucket names are unique, so you just have to find one that is not used by someone else. And I think maybe there's a difference if they're private, but I'm not entirely sure. But yeah, so once you've run this setup script, you can go to here. So we're gonna do launch Doodad simple. So we have this simple script here, which is like imports Doodad, gets our arguments, and prints out the value of this argument. Now, in our actual Doodad launch code, we have the construction of what is known as a mode. So a mode basically sets up all the variables and values that you need to launch your instance. Here you'll see that you pass it the bucket name, the folder inside the bucket you want to save your files, basically the suffix of the folder. So like it would be experiments/test simple in this case. And the image ID of the image you want to launch, the key pair name of the security key you want to use, the instance type, the region, whether you want the instance to delete itself after running the experiment, the bid price, and the Docker image that will be run when you launch the experiment. So there's like a lot of variables in here. You can actually like go look, and there's a few more if you want to configure specific settings. I think the biggest one is probably the instance type and the region in terms of like the compute you're going to get and the price you're going to pay for it. The rest is just personal preference and how you want to organize your result files and your structure of your experiments. The next thing here is a mount. This basically is saying, okay, a mount is essentially just a directory that has been zipped up and uploaded to the Docker image that you're going to run on. So it's like saying, I'm going to put this folder from my local machine or from a remote machine or Docker in some cases, and I'm going to put that folder from here, and I'm going to move it just to a different location on the target machine so that I can access it from inside my code. So in this case, the only thing we're mounting is just the actual Doodad project itself. This allows you to actually import Doodad to the script that you're using. And the Python path argument here just appends the location of this mount to the Python path on the remote instance, which will allow Python to find it and import it as a module. Yeah, and so we specify the argument dictionary here, and then lastly we just call launch Python with the Python script name that we want, the argument dictionary, the mode of what the instance type and structure we want, and any mounts that we need to create. And if we run this code, oh, we will see that it's not working. So I will run the setup script again. And while I run this, if anyone has any questions, I can answer them.
I think one of the main things that I'm looking to use it for is to do just like essentially multi-processing. So just like parallelizing a for loop.
Sure.
And so like to do that in Python, you use like the multi-processing package or some variant of it. Sure. Do you know, I'm not sure it's kind of specific to that package, but do you know if that will just like interface with the cores, like multiple cores that you have when you have an instance?
Are you saying across multiple instances or just on a single instance with many cores?
Yeah, just on a single instance.
Yeah, that'll work totally out of the box. I mean, that's like I think that's just a Python primitive. So yeah. Assuming your Python's working correctly, I think you shouldn't have any problems.
Okay, great.
I think the alternative to doing that is using MPI, which is a lot more finicky to get working, I think. Mm-hmm. So yeah, if you use multiprocessing and subprocessing, it should all work fine.
Cool.
So if when I've used AWS before, it's just been me that's had to have access. So I just had the key locally on my machine, SSH into it, real easy. So how is the best way to work if Josh and I both want to be able to SSH into the machine,
into the same machine? I think. Yeah. Okay. So I think the technically correct way. It just depends on how risk averse you are. The correct way is to basically create it with one security key and then go in and modify this SSH key like environment register for there's like an SSH key login. It's not like I'm trying to think of the term, like a registry. So, on Ubuntu, so you can add extra SSH keys. So you can actually just add the other person's personal SSH key if you want.
Oh, okay. Okay, that's not bad.
How I've done it when I'm sharing the key between multiple machines is I just put it on a thumb drive, or I'll put it on like a Dropbox and then delete it. It seems like I haven't had any problems, but there's a risk factor there.
Sure.
And I think if you're monitoring your computer, like all they can do is SSH into your machines and potentially launch something.
Yeah.
Actually, they can't even launch anything without your credentials. So I think it's pretty much just SSHing into your machines. Okay, so I think it's fairly safe.
We can either share the key or just add one.
Yeah. Share the key or add additional SSH keys to the manifest. Or there's a term for it. I'm totally blanking.
Yeah, whatever. You got it. Cool.
Yeah. Thanks. Yeah. So hopefully this works now. I'd be really sad if it doesn't.
Sorry, Blake. I also have to jump to another meeting.
Yeah, no worries.
And share the slides afterwards. This has been really helpful, though. Thank you.
Yeah, the slides have some of this code in there. I also think there's going to be a recording available potentially too.
Oh, fantastic. Thank you.
Cool. So hopefully this works. Oh, this is the wrong one. No. Okay. Okay, so let's see. Yeah. So this should launch an instance. And then I think that basically the gist of it is pretty simple. So if it's not super helpful to painstakingly go through the entire process, feel free to just ask your questions and then I can just post the code online for people. It just depends. But so you'll see this instance basically launched with the desired type. If you go to my spot request tab here, you'll see that I have made a request with this bid price that I set in my code. and that if this price ever exceeds, the P2 price ever exceeds this price, then my instance will probably be terminated. But you can set this price however you want. So if you really want a job to finish, you can set it to like $1 above asking price, and then in the worst case, you're paying $1 more, but you probably won't.
And where is the asking price?
Yeah, so that's a great question. So if you go to spot requests, there's actually a pricing history here.
Oh, cool.
And you can look at the different instance types. For what your guys are doing, it's probably going to be mostly P instances, P2 instances if you want GPUs,
Yeah.
or I guess C4, C5 compute instances if you just need C.
What about the G instances?
G instances, so I think the way the GPUs that they use are graphics heavy. So if you're doing a lot of rendering for vision or something like that, then I've used those in the past. But if you're doing it, like if you have very large models and you need
use
a good
P.
amount of just raw compute for like tensors, then probably use a P2 or P3.
Okay, cool.
So if we see this instance here has launched, it should be potentially shutting down
I'm
at this
sorry,
point.
just one last. That's
Yeah.
They say max price. Is that price per? What's the unit price per?
Per hour.
Okay.
Yeah. So I don't. How many instances? How many credits have you guys been assigned?
I think each of us has like 500.
Okay. Each group.
I think each per person it's $500.
Oh, that's not bad. So I mean, if you're launching like 10 plus instances with GPUs, like that'll eat up pretty fast. So definitely keep an eye on like I have some price saving recommendations in a slide after this works. But yeah, so there's definitely some ways you can save a substantial amount of money, and money like save a substantial amount of your compute resources. So if I go to my bucket here, which is in the S3 tab of the services. You'll see this is the one folder that Dooded has created. It has created a logs area, and then I chose my prefix to be experiments, so it's going to be stored in here. Test simple is the suffix for my experiment that I'm running, and then you'll see, well, I have a lot of files in here because I forgot to delete them prior to showing you guys, but I think it should be in here. Where is it? 5:33 p.m. This guy. So hopefully, if all worked, then basically Doodad always dumps your standard out to a file so you can see it, and hopefully we'll see a little MIT in the bottom that says like, "Yay, we are go MIT" or something to that effect. Yeah. See, so this was the output of our script. The input argument was MIT, and so this is clearly working. To do a slightly more complicated version of this, we have two scripts here: get metrics and launch metrics. So all this mode code and everything is exactly the same, but we're going to create two mounts. We're going to create a mount for the data, or for a module that is in utils and basically gets the mean and standard deviation. It's just like a dummy module to see if we can import a function from a script, and it's going to mount that to a location and add it to the Python path. So the utils module will be available to whatever Python we run, and then I'm going to mount my data file, which is just a NumPy array with some numbers in it, to the data directory on the remote machine so that I can access it in the way that I'm doing here, which is just to like load it from NumPy. And then I'm creating an output directory. This output flag basically says that it's an empty directory, and it's just there so that Doodad knows to sync the files from that folder into a folder on S3 for you to see. I'm going to go ahead and actually just delete these so it's not confusing, because I haven't run anything yet. So if we look at this code, it's all pretty similar to before. We're just adding another mount for the data, the util, and we are not passing any arguments because our function doesn't actually take any arguments. And I think for simplicity, okay, yeah, so and our experiment name is different, so it should be saved in a different place. Okay, cool. So let's just try to launch this, and then I think I can just give you some cost-saving ideas, and then any other questions you have, we can go over and then call it a day, because I'm going a little bit over time. Oh, whoops, I didn't. My AWS account is only allowed to have one instance at a time because it's a personal account. I think your MIT accounts probably won't have that restriction, but if you do, you just go to this limits tab and you can request an increase in whatever the quota is that you need. Oh yeah, it terminated automatically because I set the terminate trip flag to true. So hopefully this launches and we will see a text file with the value, the mean and standard deviation of the data that we sent. Yeah, but that might take a while. So if you have any other questions, concerns,
I think I'm
nothing.
pretty set.
So we'll check if this worked, but I think just like quickly to go over ways to save a little bit of money. Just try to develop as much locally as possible. Like don't run debug jobs on instances if you can help it, because a lot of the time you can scale up the model size, but you can test if your data is good locally. You can test if your model is compiling and like all of your stuff is the right size, and there's a lot of things you can do. Always, I would say this is like not the point of this discussion, but I will say just always check your normalization, because I am crippled by normalization errors all the time, and that's like by far the biggest error I've faced in my research. The big thing here to save money is to use spot instances. This is why I think you should use Doodad if you can, because it just makes using spot instances a lot easier. But spot instances can be 5 to 10 times cheaper per hour for the resources you're getting. The caveat is they do die sometimes, but I think if you're keeping an eye on the pricing, it's very rare that you're going to see a sudden spike in pricing with no notice. It's like very rare. I think using the P3 instances, which are the faster GPU machines, those can be, there's a very limited pool of those, so they can be hard to get. But I think P2 should be good for the stuff that you're doing for the most part. I would say only use GPUs if you really need one. A lot of the models in RL are actually fairly small, and the computation cost is like doing simulation and a lot of parallel threads at once. Depends on the architecture. There are some really large ones too, so it just depends on what you're doing, especially if you're using vision. You might need GPUs for rendering. And I think so aside from spot instances, the best way to save money is to make sure that you pick a good region. There are many different regions that you can choose from, and they have substantially different pricing for storage and for instance upkeep. I think that the Virginia, the East Coast, it's like US East 2 or like the Virginia or
yeah, Ohio, I think.
Yeah, Ohio or Virginia are the two like cheapest ones that are within, like that are going to have like a reasonable ping for you to not like lag super badly when you're using them, depending on where you are, because I know everyone's scattered now. So just pick the one that's like a good trade-off between price and usability for you. If you're running a lot of stuff automatically and you don't need to SSH in and do a lot of manual things, then it might be even reasonable for you to just use an instance that's really far away if it's cheap. It just depends on like what your workflow is and what you are willing to put up with, I guess. And also, you can the intermediate files that you get when you're training can build up really fast, like up to terabytes of data, just if you're just like letting it go for a long period of time. And that can really add up and eat away at whatever credits you have, because one AWS charges per API request. So like if you have a lot of small files, it eats away at that pricing, as well as just storage of bytes. So I think once you have an experiment that you know works, you can just save the final model file. You don't even need to keep around like a lot of your figures. You can just keep what you need to make any plots for your presentation and just like kind of try to cull stuff as you go. Because I've had situations in the past when I was less experienced where I would have tons and tons of these files around because I was worried I wouldn't be able to like generate a plot that I needed. But 90% of it is really never useful. So especially if you have a bunch of experiments that don't work, then it's like you should just get rid of like 90% of that stuff, and you'll be saving a lot of money in the short term or in the long term. But yeah, so I guess I'll just check if this worked, and that's kind of my spiel, I guess. I don't think I have any more slides. So yeah, and I'm also I'll try to be on the Piazza if people have more questions or like debugging issues. I've dealt with a lot of the minutia before, so I can hopefully be of assistance. Although it can be a bit of a slog of an API to use compared to some other services. So let's hopefully see a file here. Yes, so we've created a text file, and if we open that up, and you can always browse your files in here. But so just the point I was talking about earlier with buckets is like you can't pull a folder called outputs. There's no such file. There's just a bunch of like there's keys that have like the entire prefix of the file and the name of the file. So you'd have to like basically pull the entire path like up to here And you can actually get that in a nice way by like copying this, and it'll copy the entire path for you. And you'll have to pull that and then add like an asterisk to the right to pull all the files from inside. And then you can exclude and include different file types if you want. That's sort of the best way to pull large amounts of files at once. But yeah, so we can see that we created this text file, we browsed over to it and looked inside, and it has our mean and our standard deviation. And that's sort of, those are like basically how you use Doodad, but I think it can be a little finicky to get stuff right, so it just depends on your use case. But yeah, I guess if you don't have any more questions, we can call it. And I hope it was at least somewhat useful. I think the actual setup is a little bit like tedious and not that informative, but it can be good to have a reference in case you get stuck doing something.
Yeah, super helpful. Is there a so I think I'm pretty good on it, though I've not used Doodad before, so I'll have to mess around a little bit with that. Is there like a good email to shoot you an email to if things are getting buggy?
Yeah, sure. So you can get to me at btakel@berkeley.edu. I'll write it in a note. So just